Chapter 11. This is more so pre-geometry than it is pre-algebra, but they are both going to be helpful to you as you move forward with high school math in the years to come. So certain angles, we've talked about angles within triangles. Now certain angles, just in general, have special relationships. So as you can see, like looking down here, this thing has angles, but this is not a triangle. So there certainly are angles inside of shapes, but there can be angles that are not related to a specific shape too. Certain angles have special relationships. For example, these pairs of angles can be congruent. Lots of the relationships we'll look at will tell us the two angles are congruent. That means their measures are the same. They're both 35 degrees, or they're both 42 degrees, or whatever. There's also a kind that always add up to 90 degrees, and there's also a kind that adds up to 180 degrees. So I actually put this point first on the lesson to try to give you almost an outline before we start, because we're going to talk about several different kinds of angles, and almost all of them, the conclusion is, if they're this kind of pair, they're congruent. Or if they're this kind of pair, they're 90 degrees. They add up to 90 degrees. Or if they're this kind of pair, they add up to 180. There's one or two exceptions, but all the rest fall into one of these three categories. Speaking of exceptions, let's talk about adjacent angles. Now, adjacent actually isn't just a math word. It's just a word that means next to. Like the person to your left is adjacent to you. The person to your right is adjacent to you. Your next door neighbor is adjacent to you. These don't have to equal each other or add up to anything in particular. It's certainly possible that they do, but all the adjacent means is that the two angles are next to each other. So that's all we know for sure about two adjacent angles. They're next to each other. So if you look at this, 1 and 2 are next to each other. So they're adjacent angles. Yay! 2 and 3 are right next to each other. So they're adjacent angles. But 1 and 3 are not right next to each other. They're getting split up by angle 2. So since 1 and 3 are right next to each other, they are not adjacent angles. So that's type number 1. Type number 2, vertical angles. Now this falls into the category that if they are vertical angles, they are always congruent to each other. And when you have two lines that intersect, they're always directly opposite each other. So we've got this line and this line. And then if you look, 1 and 3 are directly opposite each other. They're the same angle, just on opposite sides of the two lines. So 1 and 3 are vertical angles, and thus, I really should say congruent right here. Sorry, in geometry they'll be very particular about that, so I should be too. So angles 1 and 3 are vertical angles, and all vertical angles are congruent. 2 and 4 are also vertical angles because they're across from each other. You can also think about it as 2 creates a V, and 4 creates a V that's directly opposite it. So they're also congruent. But I do want to make one thing clear. It is absolutely true that 1 and 3 are vertical and they're congruent to each other. It is absolutely true that 2 and 4 are vertical angles and they are congruent to each other. But that's two different pairs of vertical angles. So just because 1 has a vertical angle and 2 has a vertical angle, that doesn't mean 1 and 2 are congruent, because they're not vertical with each other. So 1 and 3 are the same or congruent as each other because they're vertical. 2 and 4 are congruent because they're vertical with each other. That doesn't mean that 2 and 3 are congruent, or 1 and 2 are congruent, or 1 and 4, or anything like that. It's only the pair that are actually vertical with each other that are congruent. Okay, now complementary angles. These are pairs that always add up to 90 degrees. So here's a couple ways you can remember this word. We know 90 degrees means it's a right angle, and complimenting other people is always right. However, another way you can remember it, this word is not actually the same stem or root as the word compliment right here. This compliment with an I after the L is talking about saying nice things, encouraging other people, things along those lines. This kind of an E after it, it certainly does have this meaning in math, but it has meanings elsewhere too. It is a good thing if a couple is complementary to each other, meaning their strengths and their weaknesses actually help offset each other's. In other words, when talking about like a husband and wife, if they're both bad at handling money, that can be a problem. But truthfully, if one of them is good with money and one's not so good, that usually works out okay because their gifts complement each other. Where one is weak, the other is strong. Where one is strong, the other is weak. That's okay. Now, it's certainly okay if they're both strong in something, but complementary means they fit or they connect well together. So it's right and it's good when a couple has a complementary relationship where one is weak, the other is strong, and they help each other in that. And this one is supplementary. Supplementary angles always add up to 180 degrees. They also form a straight line. So you can see these two angles right here add up to 180 and they form a straight line. So they're supplementary. These two add up to 180 and they form a straight line. So they're also supplementary. Now there's some more pages coming. I'd recommend you pause here and just kind of refresh and make sure you understand these three types. Adjacent, vertical, 4 types, complementary, and supplementary. From my experience in teaching this in the past, each individual one really is not that hard at all. But trying to remember which is which and putting them all together, that's where it really takes some time to organize your thoughts and make sure you understand the vocabulary terms well. So hopefully you pause, let yourself process. Now another special kind of, or special types of angles come when you have two parallel lines, meaning they're going the same direction. And I'll just tell you, they're almost always drawn horizontally. They don't have to be. Like I could just as easily draw two parallel lines going this way and then have a line going through them. So I know all the examples I showed, at least on this page we have, I made the two parallel lines horizontal. It's certainly common, even textbooks use that, but it does not have to be that way. As long as there's two parallel lines, no matter what direction they're going, these will come into play. So just a reminder, parallel lines are two lines that never touch. They have the same slope, they go in the same direction, they never intersect. And then what they call this third line, so we have the two parallel lines here and here. What they call this third line that cuts through both of them is the transversal. So what you will hear more times than you can count in geometry is, if two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, and if two parallel lines are cut by a transversal, oh man, I'm bored just saying it. Whew. But the relationship between the angles is important. So first of all, we're going to talk about alternate interior. So there's a reason I've been trying to emphasize what the words mean. They really help you process when you're thinking about these that have the two parallel lines and then the transversal. So alternate sounds like alternate, means you go from one side to the other. Interior means inside, like the interior of your car is the part you sit in when you're riding on the road. The interior of your house is where your bedroom is, your kitchen, all those things. So alternate means opposite sides or different sides. Interior means inside. So if you look at this example right here, this angle right here and this angle right here, they are on alternate sides of the transversal. One's on its right, one's on its left, and they're both between or inside the two parallel lines. So they're alternate because they're on two different sides of the transversal, and they're interior because they're both inside or between the two parallel lines. Turns out alternate interior angles are always congruent. I gotta remind myself to edit this so it says congruent. They are inside the two parallel lines and are on opposite or alternate sides of the transversal. Now, I drew two examples here so you can see that there's actually two different pair of alternate interior. There's the one here that's bottom left and upper right, but there's also the pair that's on the upper left and the bottom right. I just drew two arcs just to make it clear it's a different thing we're talking about than over here. But they are congruent. So these have the same quality. They're on opposite sides of the transversal, and they're both inside or in between the two parallel lines. So just like this pair is alternate interior, this pair is too. Then there's alternate exterior angles. They are also congruent. So if you look at the words again, it's very similar to what we said up here. They're both alternate. So that means in both of these pairs, the angles are on opposite sides of the transversal. One's on the left, one's on the right. Now where the words are different is this was interior, this was exterior. The exterior of your car is the outside of it. That's the part that gets washed when you go through a car wash. The exterior of your house is where you see the windows and the siding or the brick, whatever your house is made of. Exterior is the outside. So they are outside the two parallel lines, just like the exterior of your house is what you see on the outside. Oh, sorry, I had yawn all of a sudden. And they are on opposite or alternate sides of the transversal. So that's talking about this angle right here, and this angle right here. They're alternate because they're on two different sides of the transversal. They're exterior because they're both outside the parallel lines. And just like with these, we have two pair of them. One pair is lower left and upper right. The other pair is lower right and upper left. So those are the alternate interior and alternate exterior. And I hope if you look closely at the pictures, you can kind of see, oh, those do look really similar. I see why they're congruent. Next up, corresponding. Corresponding angles are congruent. They are in the same positions on the parallel lines in relationship to the transversal. Okay, first, before I talk to these pictures, I want to just help you with the word corresponding. So let's say you're a singer. You know, a quartet often has a bass, a tenor, an alto, and a soprano. And just, I'm going to try to give several different examples. So if you're not a singer and this doesn't make sense, that's okay. Let me get to another example soon. So you might have a quartet from Gaston Christian, and you might have a quartet from Charlotte Christian. Well, the tenor here at Gaston Christian is in a corresponding role in the quartet to the tenor in Charlotte Christian. Are they the same person? No, but they are playing the same part in the quartets. They're both the tenor, so they're corresponding roles. Might be an easier example. Right now, this year, Dr. Hewitt is the principal of the high school. Mrs. Rabb is the corresponding administrator in the middle school because she is the principal in the middle school. Or Miss Alston is corresponding because she's the principal in the elementary school. If you're a sports person, you could think, okay, the quarterback for the Panthers, he's in a corresponding role to the quarterback for the Giants. So they're in the same position, just on different teams. So if you think about these two lines cut by a transversal, you really end up with a group of four right here. Got 1, 2, 3, 4 angles. You've got a group of four right here. where you get 1, 2, 3, 4 angles. So once you understand that we really have a total of 8 angles, and they're in a group of 4 on top and a group of 4 on the bottom, I think that'll help this make more sense. So when we draw them horizontally, like I talked about, you've got a group up here of 4. The one in its lower left is corresponding to the one in the lower one's lower left. Here we have the upper left. Down here we also have the upper left. Then we have the lower right and the upper right. So corresponding means they are in the same relative location in 2 different groups. So just like there were 2 pair of alternate interior, 2 pair of alternate exterior, there are 4 pair of corresponding. And each pair is congruent. Again, just because this pair is congruent doesn't mean they're also congruent to these 2. We're just saying these 2 are congruent, these 2 are congruent, and then keep going like that. Okay, last page. Let's practice. So we want to name the pair of angles we see. That's what they mean by classify. Say what term describes them. And then we'll find the value of x in each figure. So remember, the terms we got to remember, the names are adjacent, meaning next to, vertical, meaning across from in two lines, complementary, adds up to 90, supplementary, adds up to 180, then alternate interior, alternate exterior, and corresponding are all congruent. So I believe that's a total of 7 different ones we got to remember. So I look here, I see just 2 lines, nothing parallel going on, just see 2 lines, and that one are directly across from each other, so they are vertical, because we got a V here, and then this is kind of the reflection of the V right here. So these are vertical angles, and you got to remember that vertical angles are always congruent. So you would say they're vertical angles and they're congruent. You actually didn't have to write congruent. You do have to write vertical. But since we know they're congruent, that means if this one is 108 degrees, this one is also 108 degrees. Okay, number 2, we see a right angle. That should be a huge hint. A right angle is 90 degrees, and 90 degrees, when 2 angles add up to 90 degrees, they are called complementary. So what I know is if I add those 2 together, they will add up to 90 degrees. So to find the one I don't know, I can subtract 27, and I get 63 degrees. Okay, for this last one, we see there's a straight line that gets formed. So x and 55 form a straight line. Well, to form a straight line, they must be supplementary. They can also be called a linear pair, but you'll use that term more so in geometry. But they form a line, so they're a linear pair. And we know if we add these 2 together, the sum should be 180 degrees. So if we subtract 59 from both sides, we will get that the missing angle, sorry I read that wrong, my eyesight's not very good, that's 55 degrees. So we'd add x plus 55, subtract 55, I knew something was off, that's why I paused. So make sure you write the angle down right, especially when it's right in front of you. So x plus 55 has to equal 180, so we subtract 55 from each side, meaning the missing angle is 125 degrees. That makes the 2 of them add up to 180, which means they are supplementary. Okay, now let's practice with this. So A and B are parallel. That's what this symbol right here, this isn't letters. That's A and then 2 straight vertical lines, B. Those 2 straight vertical lines are the math way of abbreviating is parallel to. So A is parallel to B. So we'll just call this line A, this line B, and T, this line up here, that's the transversal. So if the measure of angle 2 is 37 degrees, find the measure of the angles below. Explain your reasoning. And by explaining your reasoning, I'm just asking you to name the relationship that helped you figure out what the angle was. So for example, if we know angle 2, that's 37 degrees. Angle 3, we got to think, what is the relationship between angle 2 and angle 3? Well, it can't be one of those special ones that has to do with the parallel lines, because all I have to look at is these two lines to figure out the relationship between 2 and 3. It would be that they are vertical, because they're across from each other where two lines connect. So it's vertical angles, and we know that vertical angles are always congruent. So if 2 is 37 degrees, then 3 is also 37 degrees. Now the fuller explanation would be to say, because angle 2 and angle 3 are vertical angles, they must be congruent. Therefore, if angle 2 is 37 degrees, angle 3 is also 37 degrees. I'm going to say if you write vertical, good to go. Number 5, we're going to find out angle 4. So we're right here. Now, we could use either of these to do the relationship, because 2 has a relationship with 4 and 3 has a relationship with 4. But either way, both of them, if you look at angle 2 and angle 4, they form a straight line. If you look at angle 3 and angle 4, they also form a straight line. It's going in a different direction, but it's still a straight line. And any two angles that combined form a straight line are supplementary. And that means they add up to 180 degrees. So I know that angle 4 plus 37 degrees will equal 180. So I subtract 37 from both sides, and I get that the missing one will be 143 degrees. Okay, angle 8. Since we just found angle 4, I'm going to use it to help us find angle 8. So let's look. We're now dealing with two different parallel lines, so we're back to those 3 we learned regarding that. So we have 2 parallel lines cut by a transversal. We have a group of 4 up here and a group of 4 down here. So angle 8, that's in the lower right part of the angles down here, lower right, and so is angle 4, the 143. So angle 4 and angle 8 right here are corresponding to each other because they're both in the same location in these groups of 4. And we know corresponding angles are congruent. So if this one's 143 degrees, then this one is also 143 degrees. Okay, last one, angle 1. You could find this a number of different ways. I'm just going to keep going though with the order we found things in. Like they gave us 2, we used that to find out 3, we used 3 to find out 4, 4 to find out 8, etc. There are other ways, but I'm just going to choose to keep going in that rhythm. So we'll look at angle 8, which we just found, and look up here at angle 1. So as I look at 8 and 1, I notice they're on opposite or alternate sides of the transversal. So they're on opposite or alternate sides, so that's where alternate must come in. So I'll just go and write alternate. This one's on the left of the transversal. This one's on the right of the transversal. So they are, no, sorry, I'm repeating myself. That's the alternate part. They're both outside the parallel lines. It's hard to a minute to get on track. They're both outside the parallel lines, so that means they're alternate exterior. And alternate exterior angles are congruent, so if this one's 143 degrees, this one is also 143 degrees. Okay, we've come a long way. Let's look at this last one. So I want us to, well, let me just read it and then I'll talk about problem solving for a second. This says find the value of x. So we have 2 angles. Both of them have variables in it. Both this angle, MJK, and this angle, KJL, have variables in them. So you gotta think, okay, this is part of problem solving. You think, what I'm trying to figure out is the value of x. I know that because that's what it says right there. But then you say, okay, what information do I have? Well, I have the measures of these two angles, but I only have them in terms of x. And you think, okay, what other bit of information do we have? Well, we can see these two angles form a straight line. And what we learned in this lesson is that two angles that form a straight line add up to 180 degrees. So these two triangles are supplementary, so we can add the two of them together. And we know that when we add them together, they should add up to 180 degrees because they are complementary. Nope, using the wrong word. I'm sorry. Supplementary. They form a straight line. They add up to 180. So now I can combine like terms. 2x plus 3x is 5x. Negative 10 plus 15 is plus 5. I know that's equal to 180. I subtract 5 from both sides. I get 5x equals 175. And then I'll divide both sides by 5. And when we do that, we get 35. So x is equal to 35. And one brief thing I want to explain, they did ask us to find the value of x. So we've done all the work we needed to do. We said x is 35, we're done. There are times they'll do it just like that. There's also times where they'll say, tell me the measure of this angle. To do that, we'll have to take the value of x and then plug it in for x. Now they didn't ask us that, so I'm not going to finish that out. I just wanted to remind you to pay attention to what they asked for. If they ask for x, then once you have x, you're done. If they ask for the measure of an angle, you'll need to plug that value for x in to the angle. So make a good effort to memorize the terms I'm talking about, or the terms I've taught you, and what they mean. That will make an enormous difference if you have those in your brain.